Carrying the message, secret communication. Okay. Conversation of ordinary plain text into encrypted text and vice versa. Is a method to protecting information through some codes. Okay. Cryptography means the only those whom message is sent can decode protecting information. Okay. So the next term we had is hashing. So can anyone tell me what is hash or where we use it? uh, Converting text into hash code, secure algorithm. Okay, and why we use it hash? Why we use hash? Um, okay. Yeah, so you guys think hash and cryptography both are same or totally different, or somehow both are same? Similar, different, somehow same. Okay, let me break it for you. Both are totally different and both serves different purpose. Okay, so let's go and start see what we have here. So cryptography is a technique to encrypting the clear text into scrambled code or human unreadable codes. Okay, and then using the same algorithms, we decrypt it and then get the plain text message. So when we encrypt our data, that encrypted form, we call it as a ciphertext. Okay, so we're going to use that ciphertext, send it to the receiver using insecure channels like internet, emails, or any online forums. And when receiver received the message, they can run the same algorithm to decrypt that message and see what is in there. Okay, that can be done with two different ways. So first type of cryptography is symmetric, where we use single key for encryption and decryption. Okay, so think it on that way. You have one key that can lock and unlock. So that means I have to share that key to the sender, or sender have to know the key in order to decrypt the data. Right? Now, is there any problem with this particular setup? Can anyone tell me there is any issues with this thing? Let's suppose I have to send an encrypted message to someone. I encrypted the message using symmetric and then send it to some other person. Key can be hacked. Yes. Not any hacker can get the code. The problem with this particular thing is you have to pre-share your key to the receiver. If you are sharing your key over insecure channel, there is a chances it will be intercepted by hacker and use that same key to decrypt your message, make the changes, encrypt it again, and send back to the receiver. So when you use symmetric encryption, there is no way to tell when this file was last opened or edited. Right? It's just like a guest book. I guess you guys have seen this kind of guest book on different places, right? In tourist place, they have a notebook where you can go and write your feedbacks. Now, what could go wrong with this kind of thing? Like anyone can go and write stuff, right? And these are two things. Either you can write on a new line where you're supposed to write, or you can write or overwrite someone else's message with your feedback. Okay. So symmetric encryption is having few advantages. First advantage is it's fast. Second, it's reliable. Okay, but there's a few disadvantages as well. So first is they use the same key. So if that key is compromised, the hacker or the person who have access to the key can see the message. They can decrypt it, encrypt it, and then play along with that particular thing. Second, it's when it comes to multiple peoples, it's hard to manage that particular thing, right? So let's suppose you have to change the key, so you have to send the new key to each and every individuals again, right? So everyone have to know the new key, so they can start encrypting and decrypting message using the new secret message or key or passphrase. Okay, so common encryption algorithm that we use for symmetric is AES and DEG. So and it's DES, not DEG, and this is AES. Sorry for my typo. Okay, so DES was the first encryption module, and the second one we got is AES, that is Advanced Encryption Standard. Now, what is that means? So these two algorithms are uses different set of rules to encrypt or decrypt your data. So there is a like CBC and other different algorithms that you can use. So we're gonna look into that one later on. Okay. Next one is asymmetric or public key cryptography. So in public key cryptography, you don't have to share anything to anyone. Okay, but there is a two things. First, the keys. So when you're going to generate a key for asymmetric, it will automatically generate a key pair. So this key pair will contain uh, two keys. One will be the private key, other will be the public key. So one key that can be used for decrypt the message all the time. Okay, another key can be used to encrypt the message. So that key that can be used to encrypting message, we will be sharing that key to the public. So people can use that key, encrypt the message, and send back to us. Now that key most commonly known as public key. Okay, so this key is available on internet. You can share it with your known persons. Okay, and the other key that can be used to decrypt the message, it will stay hidden with the person who own the key, and we call them as a private key. Now this thing is clear. There is a key pair, one key that can encrypt the message, so we share that key to the public, so everyone can use that key. Take that in plain text message, encrypt it, and send back to my email address, and then I'm going to use my key that can be used to decrypt the message, so I can decrypt the message and see what's in there. Okay, so in entire thing we have one more thing in common, that called uh, the key servers. Can we have private and public key at both ends? Yes. So each and every person, each and every individuals going to have their own key pairs. Okay, so in my case I will be sharing my public key, in your case you will be sharing your public key. Okay, so when you're going to start a communication, I'm going to use your public key, encrypt the message, send the encrypted message to you. When you are going to communicate, you are going to take my public key, encrypt the message, send back to me. Now, is any application that uses same thing that you use in your daily life? WhatsApp, yes. Can we have public and private key at both ends? Already answered. Can one private key decrypt any data? Rajat, I have no idea what you are trying to ask here. Your private key can only decrypt the informations that are encrypted with that particular key pair's public key. If anything is encrypted with your public key, I cannot decrypt it. It can be only decryptable by your private key, not mine. Is it possible to obtain private key if public key is obtained? Um, so far, there is a mathematical formula that can be used to reverse engineer that, but in reality, we have nothing like that so far. So yeah, we are safe. There is a no way you can use public key to obtain the private key. There's a no way so far. It might be happening on some South Indian or Bollywood movies, but in reality, we don't have anything like that. Okay, yeah, movie can show you anything, but in reality, that's not possible. So in that cases, we're gonna use or trust some server, right? And that server we call them as a certificate authority that will be ensures certificate validity for each and every individuals. How public key work in group communication? If you do a simple Google search on WhatsApp encryption FAQ, you will be getting that thing with infographics. Normally, what's gonna happen is when you send a message, it will take everyone's public key, encrypt the message with each everyone's public key individually, and send them. So you might have seen this kind of thing in group messages as well. If you delete something, it will delete for each and every person's. Like it won't be rendering to anyone, right? So there is a way where Facebook are using a common public key for a group. Okay, so everyone on that group can read that message or can forward that message, but it cannot be used for any other purposes. Okay, it's totally depend on the different algorithms, what they are using and what is the use cases. That really depends on that particular thing. Okay, so I'll encourage you to go and look into WhatsApp encrypted communication FAQs. They have a detailed report how that thing works. So for this entire public key infrastructure or public key cryptography, we're gonna trust someone, and that someone will be the certificate authority. Okay, so if you want, you can have your own certificate authority, or you can trust some third parties. Okay, so third party like VeriSign, then we got DigiCert, GTS, or Google Trust Service. We got Amazon. We got what else? Bluehost, DigitalOceans. The ton of certificate authorities. These are available on public. Okay, some of them have a paid plans, some of them have a free plans, and it goes on that way. Now, next thing is GAC or government access to the keys. Now, this is the one reason that makes our life take, right? Currently, I guess everyone heard about the application banning in India. And many applications are banned because of two reasons. First, privacy concern. Second, the national security concern. Now, how this application affect? So each of these applications that we use in our Android or iOS phones or even in laptops or desktops, they have their own privacy policies, right? That ensures data security or data privacy. Now, many organizations have to follow uh, the current regulations of that country where their data center are established. So, for an example, if you are running using Facebook and your data is stored on a Facebook India servers, so Indian laws are applicable on those data centers, and your data is stored on a Eastern Union servers. The local law will be applicable on that particular locations. Okay, so same with China. Now China have a secured, or you can say they have one law that gives government to power to dig through the data that they have on any data centers that is on Chinese land. So that means any servers. That doesn't mean it belongs to Facebook or Google or Amazon. Anything, any company. If they have data center in China, Chinese authority have full access to their data. So the organizations who have those data centers running over there, they have to hand over this encryption key to the government. So whenever government want, they can go and look into the information that is stored on those servers. So again, that poses a risk on national security as well as privacy. Privacy is main concerned. National security because many high ranked officials are using this kind of applications on their daily commute or into their devices that are not supposed to have any applications installed. Okay, these applications might start spying on their phones, start recording their calls, or start monitoring their activities, and that we don't want, right? So many government have this kind of policies that gives them capability to read into your informations that is stored on data centers. Okay, and every single organizations have to comply for these policies. So you might have heard Switzerland. Switzerland have very strict data private user privacy. So they never hand over your informations to any country's government. Okay, there's some other services like Cyber Bunker and um, Ghost World. They runs on international water or international places. So they are not coming into any national laws, right? So they don't have to comply any data privacy or government access to keys policies. Okay, so they are running on a isolated islands with proper setup of uplinks and stuff like that. So they are not responsible or they're not going to answer any government what they're storing and what they're processing over there, because it's on international water land. So not none of the countries that we know have authority on those places, so it's free. Then we got encryption algorithms. Okay, so first thing is we got ciphers. Cipher is a set of rules that we implement in encryptions. Okay, there's a thousands of cipher algorithms are available on internet. Even if you want, you can create your own cipher algorithm. Okay, now creating algorithm and making them as standard is a two different thing. Okay, in many organizations they are using their custom encryption cipher algorithms. Okay, now these algorithms might be secured, but we don't know yet, right? So normally when it comes to applications, we always stick with standard cipher algorithms like AES, right? Now substitutions where we change a bit or replace the letter from a different place or different letters. Okay, so one of the famous one for this was uh, Caesar cipher, where you have your alphabets and then start shifting the bits. So A will become B or B will become C. Like it's a one shifting. You can have four shifting. You can have eight shifting. So the first letter will be denoted with the eighth letter of that particular alphabets. Okay. So same ways we got poly alphabetic, where we use one key or one character denoted with by multiple characters. So for an example, if we have A, we can denote A with A, I, O, U, like vowels. So for one vowel, we can use any of these. Okay. There might be any other algorithms, like first A will be B, the second A will become Z. Okay, that just makes more and more complicated level complications on your encryption algorithm. Again, this is not an encryption, this is substitution. So you're just changing the bits. Okay, if I'm able to understand how you're changing the bits, I can reverse engineer it and get the plain text value. Okay, so far there is no encryption, just shifting the bits. Okay, and this technique is very old. Then we talk about keys. Okay, now key will be the main component or the substitutions that we are going to use to encrypt or decrypt information. Now this key is most commonly will be used as a passphrase or a password. Okay, normally we use password like 1 digit or 10 digit or 11 digit. So what going to happen is whatever we are going to type, there will be an algorithms. They will be changing my input or the key length that we have to some sort of hashing, and then use that hash to encrypt as a substitution, and then start encrypting and decrypting my information. Okay, so that totally renders the key length value in my encryption algorithms. So let's suppose there is a key set of 32. Okay, so that means I have to input a 32 character of password. Now, how commonly we can remember that long digit or that long password? It's not possible being a human, right? Either we have to save it on somewhere in written or in a desktop computers. The other way is I can use some sort of algorithms to convert any input that we are going to type to a pre-length output and use that output as a passphrase or a key. Okay, so this key most common many times you'll see as a passphrase. So you don't know the phrase, but there is a password or key that you know can be used to generate that passphrase that can be used to encrypt or decrypt the data. And the entire thing runs on two different cipher modules. First is stream cipher, where we encrypt bit by bit. So as their name is streaming, right? So let's suppose you're watching some data that is coming from one source to another source, and you have to decrypt that thing on the fly. So we're gonna have all those things in bit by bit. So when the first bit is arrived on my systems, I will start decrypting that one. Next bit arrived, we start decrypting that one. Third bit arrived, decrypting that one. So that ensures the entire communication is secured as well as the fast decryption modules. Okay, so many OTT platforms uses stream cipher such as Netflix, Amazon Prime, and others. Okay, they do have something called DRM that ensures data right policies as well, licensings. Then we got block ciphers. So as their name, we're gonna encrypt data on block sizes. Okay, and again there is a typo. I'm really sorry for this kind of typos. I guess I had some bad experience when I was typing this one. Okay, so when we talk about blocks, so there will be a certain block sizes. Okay, for example, AES 256. That is most common encryption we use. So there will be a block of 256 bits. Okay, so let's suppose there is information like hello there. Okay, I'm gonna make it as this is a 530 bits. Okay, so this encryption will be having the first 256 bit, right? The next block again 256, and the next block, because we already got 256 plus 256, how much? 512, and then minus 530. 512, and then 530 minus 512, 18. So this one going to be have 18 bits, but again it's a block cipher. Okay, so we need to the block size is 256 minus 18, 238. So I have to add plus 238, and this 238 will be the padding value. So that will be a random junk value that doesn't make any sense. To ensure we end with 256 on each and every blocks. So when we start decrypting, we know this last 238 bits are junk, so we can just ignore them and rephrase the entire plain text using this thing. Okay. Now padding value might be random, might be the same key or same repeating text. We don't know. It's based on algorithms. We have to find out. So for an example, there is an encoding called base 64. They uses is equal to sign to pad stuff. Okay, so we'll go and see that one as well. So far things are clear. Any questions? So in symmetric key, data encryption is standard, you can see it here. So what we're gonna do is we're gonna take first initial permutation, okay, and then we're gonna use our key, okay, and yes, I guess when I was changing that thing, it's changed all those things. Okay, so what's gonna happen is they'll take a initial premeditations, take the first line with the first 48 bit of my character of my key. In round two, they're gonna use the last 48 bits, run these things, go back, and they're going to use the same thing for 16 times. Okay, and after that, we're gonna get a final permutations that will be our ciphertext. Okay, now the key that we are going to use, it will be always 54 bit. Okay, and I guess that is a find and replace thing that I did on something and messed up with my DES and AES things for some reason. What I did. Okay, so they're going to use section round processing data with the section intermediately round keys with 48 bit generated from 56 bit cipher keys. By a round key generator, similar DES reverse cipher computes the data in clear text from the ciphertext using the same cipher key, and that will be the major parameters of DES. In AES, we're going to use the same technique with or more larger bit size, so 128, 192, and 256. So most commonly, all those applications that we are using or any ransomware that says military grade encryption, there is chances they are using AES 256 or triple AES 256. Okay, so there will be AES 256, again AES 256, and again AES 256. So it's 3 rounds of AES 256. So it's very hard to go back and see the data of what we encrypted in the very first place. Okay, many ransomwares uses the same technique to encrypt your informations, and so far there is no way to recover your data without knowing the exact encryption key. Okay, or the passphrase that they use to encrypt that data. Okay, in asymmetric, again it's a key pair. If you don't have access to your key pair, your private keys, there is no way you can recover the information. Okay, so whenever we do any kind of information sharing, but there is a also decryptor for ransomwares. Yes, see, encryption algorithm is secure, but the implementations, it might be faulty, right? So if they're making mistakes on how they're implementing the ransomware, there is a way to reverse engineer at it and get the data back. So for an example, we have seen ransomwares are you taking current date or email address as a private key. So knowing the email address, you can actually reverse engineer the encryption because that's your private passphrase that you used. Okay, it's 56 bits in DES. I guess I took the wrong diagram for that. Okay, again, algorithms are secure, but implementations is something that matters, right? Okay, so you guys can agree on that term, right? Awesome. So in public key cryptography, if we don't have access, like we need to access to that private key that was used to the public key that used to encrypt your informations, we need the same key pair's private key in order to decrypt it. If we don't have access to that, there is no way we can recover the information. Okay, in both keys is generated on the same time with the same encryption algorithm or key generation algorithm. Okay, so if we miss one of those keys, if it miss the public key, we can generate another public key. But if we lose our private key, there is a no way we can generate it. Okay, it's gone, data is gone. Okay, so there's a difference between these two. So you can see it here: symmetric encryptions and asymmetric encryptions. So these are different encryption modules in both ways. You can see it there. So here the most common is AES. On this side, we're going to talk about RSA, we're going to talk about Diffie-Hellman, we're going to talk about ECC, and we're going to talk about DSA later on. So these are in, we use RSA and Diffie-Hellman and ECC for our SSL and TLS communication channels. Okay. Now other thing is MAC, that is message authentication code. So let's suppose I'm sending a message, let's suppose hi or hello in chat. Okay, so I sent hello. So I guess everyone can see I sent hello, right? But what if there is a hacker who can change my text on the fly when it's going to the Zoom server and make it to bye? They can do that, right? So when Zoom's going to show this message to everyone, that will be showing you bye. But we want to ensure the user receiver is getting the same message that we are sending. If that is not the same message, send them error message saying, hey, the data is corrupted. And we can achieve that thing with a key. And the key will be generated using MAC algorithm. Okay, so whenever you receive anything on the use server receiver end, okay, your computer or your applications will look for the MAC algorithms, generate the MAC value, and matches with the value that coming with the message. If both matches, then it will show, hey, you can read this message. If that is not, you'll get a message like message corrupted or data corrupted, something like that. Okay, so there's a limitations of MAC, that's why we don't use it, and most commonly we use something called hash. Hash is much more better than this MAC thing. Okay, that was a very old operations. So there's a reference links where you can actually look into MAC and HMAC with animations. There is a PDFs available for each and everything. Okay, so I'm gonna go and show you one more thing before I wrap it up for today. That will be asymmetric. So if you wanna have your emails encrypted, go to this website. Okay, it's called protonmail.com. Okay, sign up for your account here. Okay, so in upcoming classes, where we're gonna talk about, the keys and stuff. If I remember my password correctly, that I did not. Okay, so let's go and create a new account. So we're gonna go for free plan, select free plan. So let's go. There is a two domains, protonmail.com and protonmail.ch. Can we get Classroom? And create email account. Username already exists. I can have and we got our classroom dash demo. So we're gonna click on reCAPTCHA. I am not a robot. See all image with tractors. So one tractor, two tractor, three tractor. And you see they're generating the keys for me, setting up a new account. And we're gonna see these keys where that key is stored. So we're gonna go click finish for this thing. going to the settings, going to the keys, and here we see we got our key here. So I click on export. They'll ask me, hey, what key you want to export? Private key or public key, right? So we in next upcoming classes, we're gonna export the public key and send encrypted message to my computer. Okay. So we're gonna do this in upcoming classes, how it works. If you wanna do that, we can do this today. You agree on that one? Shall I do it today? Anything? Just give me an answer. So I'll start. Okay. So let's use what shall we use then? Shall I show it on Kali Linux or Mac? Okay. So in Mac, I have to, I guess I already have this tool downloaded. In Kali, I'll show you in upcoming classes. Okay. So you have to do brew install GPG. I don't have brew installed, so I'll go and show it on your other one. Okay, I'll show it in Kali. And I guess I have access to Ubuntu machine for now. So that should be fun. Okay, so I'm gonna create a new folder, name it as a GPG, then do apt install GPG. Okay, kill 36389. So there are some process that is blocking me to use. Okay. Sudo apt install GPG. Could not connect. Okay, let's go open up Kali Linux and go from there. And Kali Linux VM. And I guess we can spend this one for now. Okay, we are waiting that machines to be suspended first. Come on. Okay, machine suspended, so we can run our Kali machine here now. Okay. I'm gonna delete this file for now. Let's have this file, doesn't matter. And for some reason, this machine lose the network communication. Okay, so if config sudo if config, we have IP address and everything looks fine. So now do sudo apt install GPG. It's already installed. Okay, so we have one file iminnocent.txt. So I'm going to use that file to play with. So do gpg-k, and we had no keys so far. So I'll do gpg dash dash generate and then key. I give it a name, so I'm gonna type my name here, ANI. Uh, okay, email address. I'm gonna play along with here. Type a fake email address. Save. Okay, and then asking me to save this thing with a password. I'm typing 12345. Take this one anyway, and then let's move your mouse to generate a random numbers. So once it's done, we should have get this message saying, "Hey, key, this is generated." So we can do gpg-k, and we can see we got root at kali.local generated successfully. Now next thing is we need this public key, right? So we'll go it here, click on export, public key. It's downloaded this file on my computer. We can actually wget on my system as well, I guess, if I recall this correctly. So wget, no, I cannot. So let's see where this file downloaded. So it's on the downloads, and the file I downloaded is class star.asc. So it's public key, right? So I just move this file to my this directory. So I can use python 3 -m http dot server and copy this file to my computer. So when I run this command, it will be running a web server on port 80. So I can actually go and wget this file now. So http 192.168.1.19 slash. Okay, we cannot copy this location. So let's go with the browser and download this file. So we need this public key on my computer. So I'm just trying to copy that one. So if I type 192.168.1.19, we will be seeing up this file here. So that is what we need to download in my Linux machine. So 192.168.1.19. You can have or directly download these things on your computer, doesn't matter, right? So copy link location, wget, and we got public key.asc. So we'll do gpg dash dash import because we need to import this key. And once we import it, we can actually check this key, gpg dash k, and we see this is the email address that we just imported. Okay. Now let's suppose I want to send this iminnocent.txt. So let's edit few more lines. Okay, so first thing is delete this thing. Hey, this is an encrypted message. If you can't read, then either you are the authorized person or NSA. Huh. So this is a plain text that we can read, right? So what we're gonna do is we're gonna use GPG, then dash dash encrypt, then dash dash r more to make sure we are treating this file as a what we can say, by ASCII character, not as a binary. And then we're gonna copy the email address. So that is classroom underscore dash demo at protonmail.com. So right click, copy email address, scroll it down, paste it here, and then file name. And then asking me, hey, we don't trust this key. Okay, so you really want to use this key anyway? I like, yes. We got nothing, but here we see we got a file. So we do cat iminnocent.txt.asc, and we got this message. Now, this is the message that we are going to send to our email address. So again, I'm going to do the same module here. So Python 3 -m http dot server on port 80. And when we run it on Linux, we're gonna get an error message like saying, hey, permission denied. So port 80 is a service port. We are not supposed to run without anything. So I guess I'm already running something on this port. So I'm gonna disable that thing. Yep, we are now running. So if you go back to our browser, that is here, and it will be 1.6 this time because it's a Linux machine. We got test.asc. Copy this, going back to my email. Again, just delete all those files. I'll go back to my mail client, going to the email machines, hit and then we're gonna send it to our I think. So the email address we have is classroom-demo at protonmail.com. So classroom-demo at protonmail.com. Subject, encrypted mail alert, and send it. Now see, I'm not sending any plain text message. So we'll refresh this inbox. It will take a few seconds to receive. And we got this one. Click on this button. And hey, we can read the message, right? Hey, this is encrypted message. If you can read this, either you're authorized person or NSA. And so as far as I'm concerned, I am the authorized person, right? Because I used my public key, this account's public key, to encrypt the message and send it to this account. And we can see this is log saying me, hey, this is a PGP encrypted message. What if I just send a normal message like classroom-demo at protonmail.com, and this will be plain text. Hey there, send it. We send this message again. So let's see. Come on. Hey, we got this message. If you open this one, and this lock is saying, hey, stored with zero access encryption. So this message will be encrypted locally on this computer, but the person who sent it, that message wasn't encrypted. But if I look into this message, we see this is a PGP encrypted message. So that was fun, right? So if you want, you can send your encrypted message to classroom-demo at protonmail.com with subject line your name and anything in your body. Okay, so try sending me some messages. Let's see what you can do. I'll just gonna share this email address on everyone in meeting. So this is classroom-demo at protonmail.com. So send your email to this email address with encrypted messages. Okay, so let's see who can send. And next class, we're gonna do our own setup. Currently, we are sending our public key with a location, right? I'll just show you one thing very quickly. So do gpg dash dash key server key server dot ubuntu.com dash search search dash keys animation raw at live.com, and you see you can actually fetch my key just using this one. So let's capture this key. If you do gpg dash k, and you see you just got my key here. And if you look into last digits, right, like cbcafd7. Now let's go back to my little tiny website and scroll it down all over. You will see this one, right? CAFD7, right? So if you send any message, you can actually identify by looking into this message saying, hey, this key actually belongs to me. And then you can encrypt message, send it to my email address, and then I can decrypt it and see what's inside. Okay, but in your case, you have to send it to classroom-demo@protonmail.com. Okay, so we'll see you on the next class, and hope you will be sending me emails before that so we can play along with that. Okay, if you're getting any other issues related to these things, then just go through, watch the video one more time. Okay, if you feel anything like you're not able to send message or something is messing up, drop me an email or a WhatsApp text, and I will help you out. So next class is on 4. So make sure you are sending your messages before that. Okay, in next class we're going to talk about the same thing with symmetric keys to encrypt and decrypt. Okay, and then using key pair, and we're going to go and make it more useful than today. And then we use hashing for data integrity. So make sure your Linux box is up and running on the next class. So I'll see you on the next class. Okay, have a nice time and see you all. So thank you everyone.